Power to the truth. This is Margo. This is Saturday, March the 9th, 2019, 5:27 p.m. Pacific Time, United States of America. So Cam's pulled a fast one on us today. My show yesterday, in that show I showed new methane data from Thursday, February 28th, and then this morning when I logged in to my computer and looked around, they had new data up for Friday. I didn't record it, and now this afternoon Friday is gone and Saturday, March the 2nd data is up. It's a week old, but it's here, so we're just going to have to imagine what happened on Friday. And so this would be where it ended on Friday, where the methane was, this big buildup out of Siberia was starting to release in the Kara Sea, plus more release to the east of Novaya Zemlya. So I have Saturday, March the 2nd pulled up with surface level view and the Arctic view, Arctic area chosen. There's also quite a release coming out of the Chukchi Sea off of this East Siberia ice shelf, and it's in this yellowy range. So from 2020 to 2060 parts per billion, and so then when you get on up in this dark range, it's anywhere from 2160 to 10,000 parts per billion. So I've got this movie loaded up for you to see. So when it runs into the forecast period, we see that release did its thing, and then now towards the end of the forecast period we're seeing a new building. So this seems to be a pattern, and this is explained now from that paper that I presented yesterday about the study that those Russian scientists did about the high levels of methane being found in the frozen ice and permafrost and the clay and all of that here on this Yamal Peninsula and in a couple of other areas around here around this Kara Sea coast. And I also want to remind everyone that this Kara Sea right here is the most radioactive sea on the planet because of the nuclear testing that was done during the Cold War on Novaya Zemlya by Russia. This was and still is pretty much a military base, and they dumped all kinds of waste products in the Kara Sea. There is a sunken nuclear submarine down here. There are spent fuel rods from reactors, and I mean, I presented that. You can do your own research and find papers on all of that, but it's my theory that this is why the Arctic sea ice is melting so fast, and this whole Arctic region is heating up so much faster because of the radioactive material that's here and the things that were done back in the 50s and 60s there. And the testing was done above ground and below ground and in the water and all over the place. And then they did have test sites at different points in Russia, and so it's a whole thing. So there's that. Now if you want to look at the global view, we can briefly look at that. just to see what that's looking like. And we're still seeing a lot of methane being released from the midpoint over to the east on the United States, and lots of being released in South America, of course China, India, and just different places. But we're really concerned about this whole Arctic region, and also Alaska and Canada, because they've got a lot of methane stored up in their permafrost as well. And as the heating is going to begin, the permafrost will be melting, and these huge stores of methane, much higher than we even imagined. And we learned from the paper yesterday that these amounts are not even figured into the climate models that they're already using. So it's pretty sobering to think about that. So there's what's happening worldwide. And while we're here, I want to peek at sulfur dioxide and show you what's going on today around the planet. Let's print this. And then I can zoom in and we can show some areas kind of close up here. First of all, the area that I'm really looking at that's of interest is right down here in the South Indian Ocean, and it's off to the southeast of Madagascar, this little island that's off the coast of South Africa. There is a tectonic plate right down there, and so what we're looking at is about right down here. So this is the Indian Ocean, and this is the Antarctic plate here. So where this plate comes up and meets these areas is it's right in here, and so it looks to me like it's plate movement is what, and so with some plate movement that can be a large release of sulfur dioxide, and it's out in the ocean. And so I can't think of anything else that would be, unless it was an undersea volcano going off, or I don't know what. But we have seen some earthquakes down there, but usually the sulfur dioxide is a precursor of what's going to happen, is what I've seen. We also have some huge releases coming out of Mexico. This is the Popocatépetl volcano area here, and then here's a second release over to the west side, to the Pacific side. So there have been earthquakes all up and down there. Then we have constant release from Hawaii. We're still having release out of Alaska. It's not red like we had been seeing, but it's trailing up. Once it releases into the atmosphere, it trails up and around, and then kind of goes out, just gets on that crazy jet stream, the looping jet stream, and then it's swooping down into Canada and coming down into the United States, and then spreads out over the northern Canadian regions, and then the Arctic as well. And we have release coming from Canada all the way across and out over the Atlantic Ocean. And then we've talked about sulfur dioxide over here from India and China and Saudi Arabia. That's industrial, I'm thinking. So there's that. But so we're going to be looking for earthquakes down here on this South Indian plate, the Indian Ocean, on that plate in the next few days to come. And then we'll know that we were right. So next, I've got some news items, but before we go over news, I have one comment that I want to go over. I copied and pasted it off of my video from yesterday. This came in from Nostradamus, who's our friend Dave from the UK. And he says, "Hi Margo, I've been number crunching raw data on average atmospheric methane concentrations from the METOP satellites over the past 7 days." Now this, for people who don't know, this is out of NOAA. And there are 2 satellites that go around the planet measuring methane and other greenhouse gases as well. So here he's got them for and then the satellites take a reading. They both take a reading in the morning and then in the afternoon. And so here he has METOP 1 in the morning, and the level is 477 HPA. And from March the 1st it was 1870 parts per, these are parts per billion, and this is global average mean. So what that looks like, let's just go back to methane. Let's go back to surface. Well, let's see if 500 HPA is working. Okay, so it's about this level that he's talking about, 477. It's about this level, and so the 18, what was it? I'm having a brain fart. 1870. Okay, so I'm going to refresh this. Okay, now this is interesting. I did find that when you change levels, it doesn't automatically change the color chart, but if you refresh after you change the levels, then you get a new color chart. They have a different color chart for every level. I discovered that about a month ago and didn't say anything. So 1870 is about right here, this chartreuse color. So that's if you average out all of these colors and all of these readings, all these colors, if it's averaged out, would have been on March the 1st from that one satellite about this chartreuse color, about that color right here. And you can just imagine that color covering the planet. That would be the average, okay? So let's go back to his comment. And then from the same satellite in the morning on March the 8th, the reading was 1878. So it was 8 points higher. And then for the METOP 1 in the afternoon at 496 HPA, from March the 1st, it was reading 1869, so that's close to 1870. But then on March the 8th, it was reading 1870. So that's 1 point higher. And then on the Met-Op-2 satellite in the morning at 496 HPA. On March the 1st, the average was 1845. Then on March the 8th, it was 1850, so it went up 5 points. And then the Met-Op-2 in the afternoon at 496. From March the 1st, it was 1845, so same reading as the Met-Op-1 satellite. But on March the 8th, it was 1847, so it was 2 points higher. So he says the average increase works out at 4 parts per billion over the 7-day period. I plotted this as an extension up to the end of this year at current rates to a graph published in March 2017. Bear in mind, my straight line projection assumes linear continued release of methane without any accelerated emissions. Hope you can share my findings. Much love. And then here's the chart that he sent. It's kind of small, so we have to blow it up. And this chart he created on the NOAA website. There's their logo down here. So what we're seeing, global mean, monthly mean for methane, CH4, and so here it is from 2019, and here it is. This is parts per billion, and so this is where we are right now, about 1850, and then if it keeps increasing like he saw, and so he might be tracking this for a while, by the end of the year it looks like the global mean can go up to 2030 parts per billion. So that's the average of all of them. So from 1850 to 2030. So that's pretty high. But it could even go higher than that. So I'm thinking it could go higher than that, because we're gonna be it's the middle of winter, and if it's increasing 4 parts per billion in a week in the middle of winter, just think how much it's going to be increasing in the summertime. So not looking good, folks. It's not looking good at all. So let's print that. So thank you, Dave, for that research and sharing it with us. And we'll just move on from there. Now, I have some, just a few news items that I want to run through with everyone. The first one is from Eye on the Arctic, rcinet.ca, and it's called The Island That Disappeared in Arctic Russia. The Independent Barents Observer. Perlemutrovi Island in Franz Josef Land, Arctic Russia, seems to have completely vanished. So there's a picture of the ocean. It was discovered in the early 20th century and has since been part of all maps of the Arctic, but now the island of Perlemutrovi has simply vanished. The island was located near the Graham Bell island in Franz Josef Land, the remote Russian Arctic archipelago, and had a name that means the mother of pearls. It had a round shape and a diameter of 1.5 kilometers. Its highest point was 22 meters above sea level. It was all covered by a glacier. That is now all history. The island of Perlamutrovy is simply gone, and nobody seems to know exactly what has happened. Russian researchers suspected the disappearance in 2017 when they failed to discover it on satellite photos. In summer of 2018, hydrographers from the Russian Northern Fleet during an expedition confirmed that the island is gone. On the site is now only open water, the researchers make clear. It's very important to understand the reasons why the island has disappeared. They're confident that it's related with the rapid climate change in the area. On the nearby island of Graham Bell, we see processes of coastal erosion, and perhaps the small neighboring island was washed away, that the currents changed and the seafloor came into motion, but that it became a so-called walking island. It is not the only remarkable geological change that now is unfolding in Franz Josef Land. Over the last couple of years, several new islands have been found in the area. Only in the course of the expeditions organized by the Northern Fleet, a total of 12 new islands, 1 new strait, 14 new headlands, and 6 bays have been discovered. For the Arctic, this kind of disappearance and appearance of islands is a natural process. It is related to climate change on the planet. There are many new findings made as the glaciers disappear, and it is quite likely that the outlines of the Franz Josef Land actually are far from the ones that are depicted on maps. The Franz Josef Land is located in the northern part of the Barents Sea, an area which is experiencing some of the biggest climate change on the planet. Average temperatures in the area have hiked in only a few years. And they say the nearby Kara Sea has over the last 30 years experienced an average air temperature increase of as much as 4.95 Celsius degrees. A similar warming is unfolding in the sea. So, and then they published a paper about it, and shift from an Arctic to an Atlantic climate. We've been talking about that. We see a similar Atlantification of the sea to the north and east of Svalbard. Less sea ice in the Arctic Ocean leads to less meltwater, and thus the warm Atlantic water remains atop the water column for most of the year, staying entirely on the surface. It provides a larger ice-free area north of the Svalbard archipelago and thinner ice further to the east. And that's exactly what we've been seeing and we've been looking at. Now let's see if we can find Franz Josef Land on Google Earth, just for the fun of it. Here we go. Okay, so it's part of these islands. Oh look, here's an air base. Nogurskoy. I've read about that somewhere. So here's Franz Josef Land. Let's see if that island is mentioned here. Perlamutrovy. Let's see if we can find Perlamutrovy on Google Earth. See if it's still here or if it's gone. Nope, it's off the map. So it was in this area. Let's try it again. Okay, so it was in this area, and so you can see Franz Josef Land it's comprised of a whole bunch of little islands, and some of them are just so tiny. If it was only 1.5 kilometers in diameter, that's not very big, and that could easily have gotten caught up in rising sea levels, and if the soil eroded, the coast eroded, and and then we had some shifting of tectonic plates there. It could have happened. Here's Svalbard. So this is all Franz Josef Land. And there's, we all know, Novaya Zemlya. So there's that. So we'll leave that. So I thought that was an interesting article. So that's showing evidence of how the Earth is changing, and we will be seeing more and more and more of that kind of activity happen as we have more abrupt climate change and sea level rise and tectonic plate movements and all that. Okay, this one is out of the UK, edinburghlive.co.uk, and our friend Martian Noren sent me this article yesterday? No, this morning. And it's cracks found in nuclear reactor that could lead to the evacuation of Edinburgh. The two reactors at Hunterston B nuclear power plant near Ardrossan are 43 years old, the oldest in Europe. They're already well beyond their operating lifetimes, which have twice been extended by EDF Energy, and they're scheduled to close down for good in 2023. However, there's a serious safety fault in the reactors. The fault is known as keyway root cracking, where the graphite moderator cores in the reactors develop cracks leading to instabilities that could lead to a major nuclear accident, which would lead to a large swath of Scotland's central belt having to be evacuated. In the very worst case, the hot graphite core could become exposed to air and ignite, leading to radioactive contamination of the metropolitan areas of Glasgow and Edinburgh. The reactors have been closed since October 2018 as a result, but owners EDF Energy are currently making a case for turning them back on, with help from trade union GMB. Although the probability of a meltdown is still low, the consequences could be incredibly severe. In such an event, both Glasgow and Edinburgh would need to be entirely evacuated due to radioactive contamination. And then here's according to Dr. Ian Fairley, an independent consultant on radioactivity in the environment, and Dr. David Toke, reader in energy policy at the University of Aberdeen, the two reactors definitely should not be restarted. Speaking about the cracks in the barrels, they say, this is a serious matter because if an untoward incident were to occur, for example an earth tremor, gas excursion, steam surge, sudden outage, or sudden depressurization, the barrels could become dislodged and or misaligned. These events could in turn lead to large emissions of radioactive gases. Further, if hotspots were to occur, and if nuclear fuel were to react with the graphite moderator, they could lead to explosions inside the reactor core. The reactor core is made up of 3,000 bricks, and cracks run the full length of 1 in 10 of them. In the very worst case, the hot graphite core could become exposed to air and ignite, leading to radioactive contamination of large areas of central Scotland, including the metropolitan areas of Glasgow and Edinburgh. Nuclear safety is our overriding priority, and Reactor 3 has been off for the year so that we can do further inspections. We've carried out one of our biggest ever inspection campaigns on Reactor 3. We've renewed our modeling, we've done experiments and tests, and we've analyzed all the data from this to produce our safety case that we will submit to the ONR. We have to demonstrate that the reactor will always shut down and that it will shut down in an extreme seismic event. The operational limit for the latest period of operation was 350 cracks, but an inspection found that allowance had been exceeded. EDF plans to ask the regulator for permission to restart with a new operational limit of up to 700 cracks. That doesn't sound good. That doesn't sound good at all. So if that happened, that'd get up in the atmosphere and we'd just be that much more screwed. So if abrupt climate change doesn't kill us, one of these other things will. Okay, now I've got 2 articles from Futurism. This one is called Chemists Grow a Synthetic Brain That Stores Memories in Silver. Just what we want, huh? One of its creators thinks it could usher in the post-human revolution. Well, they're going to need post-human revolution because all the humans are going to be gone soon. Natural growth. In the ongoing quest to build an artificial human brain, scientists from UCLA may have just taken a big step forward. While a real synthetic brain is still far away, a team of chemical engineers found out how to grow self-assembling circuitry that resembles the structure and electrical activity of parts of a brain, according to ZDNet. The research is the pet project of UCLA chemical engineer James Gimzewski, who proclaimed that he wanted to create a synthetic brain back in 2012. "I want to create a synthetic brain," Gimzewski wrote at the time. "I want to create a machine that thinks, a machine that possesses physical intelligence. Such a system does not exist and promises to cause a revolution one might call the post-human revolution." Gimzewski and his team found that a grid of tightly packed copper posts, when treated with silver nitrate, grew nanowires out in seemingly random directions that mirror the branching interconnect neurons found in a brain. On the atomic scale, the connections among the silver nanowires resemble synapses, which are the junctions at which 2 neurons meet up and transmit signals among each other. The way that the nanowires organize themselves mirrors the sort of structures that would pop up during an MRI of a brain as it stores memories. When the network of wires is hit by an electrical signal, the nanowires seem to be organizing information as a brain does, all on their own. When they're all combined, they start to talk to each other. In a way, the whole circuitry comes alive, in a sense, in that every part is interacting with every other part, and there are pathways in which we can establish stronger neuromorphic connections. But he's not quite there yet. In spite of his 2012 proclamation, Jemzewski now urges caution. And so if you want to read the article, you can go to Futurism, and you can click right there and it'll take you to the original article. So, considering all the nano crap that's in our atmosphere and in the water and everything, we probably have all of these little nano circuits already developing in our brains with all the heavy metals and the toxins, and I think we're walking around with all this crap already in us and they're just trying to figure out what to do with it. That's my opinion. One more article, also from Futurism. This one, it says Zuckerberg, Facebook is building a machine to read your thoughts. Facebook Mind Reader. According to CEO Mark Zuckerberg, Facebook aims to access information about its users not just through their smartphones and computers, but directly from their brains as well. In a recent interview at Harvard University with Harvard Law School professor Jonathan Zittrain, Zuckerberg bragged about technology the social giant is working on that could one day allow users to navigate menus or even type using their minds alone. This is from Wired Reports. When Zittrain challenged Zuckerberg on the invasiveness and ethical implications of a Facebook mind-reading machine, the Silicon Valley CEO had a simple answer. Presumably, this would be something that someone would choose to use as a product. They're calling it a brain mouse. The concept is relatively simple. Smart objects can communicate with each other, but your brain is closed off from them. The solution, according to Zuckerberg, is a shower cap-looking device that will read the signals in your brain and use them to unlock the data streams of your thoughts. Facebook has been testing such a brain-computer interface for a number of years. At its FA Developers Conference in 2017, the company showed off what Facebook's VP of Building, Regina Dugan, referred to as a brain mouse, a non-invasive brain interface that could one day allow users to control AR applications. Zuckerberg's enthusiasm about that work is ironic because the company has lost a lot of trust among its users after years of bad press and repeated reports of privacy violations. Millions of Americans have left the social network in 2018. Facebook's future plans for a brain-computer interface seem oddly disconnected from that reality. Well, and then the next step after that will be, we'll just plug you directly in with an electrode in your brain or something, or the chip, you know, who knows. So I will leave the links below to those news items if you would like to see those. And Now let's get into our earthquake report. I think I should probably clear out my cookies, and we'll be right back with earthquakes. Don't go anywhere. Okay, I'm back, and so we have USGS pulled up for all magnitudes for the last 24 hours of earthquakes worldwide, and we're showing 162 on the map. So the number's gone way down from yesterday. Of course, it is Saturday. It's the weekend. A lot of the earthquake makers are at home and not working, so that can be part of the reason that there are fewer earthquakes. And but we're seeing some good sized ones in areas that we don't normally see them at. So where we have 1 day magnitude 2.5 or higher, we have 32 on the map. So let's check out our oldest ones here. It looks like the oldest one is this 4.6 down in Coquimbo, Chile, that came in last night at 6:16 p.m., 43 kilometers deep. So let's go ahead and look at that. So it's right here on the coast, actually on the land, and that came in at 6:16 last night. Then there's a 4.5 near Ovalle at 7:22 this morning, 52 kilometers deep, and then a 4.8 near Calingasta, Argentina at 12:45 this afternoon, 116 kilometers deep, all in that one area. So let's finish up in South America while we're here. 4.4 near Iquique, Chile at 10:16 last night in the evening, 99 kilometers deep. So all these times I'm telling you are Pacific time, because that's my time zone. And also we had one down in southern Mexico, a 4.7 near Atoyac de Alvarez, Mexico at 6 o'clock this morning, 69 kilometers deep. Okay, let's see what else might be. Okay, we need to go down south now to this Macquarie Island. Down here, directly south of Australia and Tasmania, right here on this Antarctic plate line in the South Pacific, was a 4.8 west of Macquarie Island at 6:20 p.m. last night. While we're down here, let's move on around. Then up here, just north of New Zealand, was another 4.9 near L'Esperance Rock, New Zealand at 8:25 this morning. Remember, we've seen a lot there, and there have been a lot more earthquakes in this area and also on New Zealand that are just not being reported by the USGS. Then here's a 4.8 near Kokopo, Papua New Guinea, that happened at 5:29 this morning, 110 kilometers deep. Next, coming on around, was a 4.7 near Barat Daya, Indonesia at 4:33 this morning, 151 kilometers deep. Coming on around, Here's one off the northeast coast of Sumatra, was a 4.4 near Banda Aceh, Indonesia, at 2:42 this afternoon, 56 kilometers deep. Coming on around this ring of fire, 4.4 near Asan Mena village, Guam. This happened at 3:13 this afternoon, 187 kilometers deep. Then we've got two in the ocean just southeast of Japan. The first one was a 4.8 in the Izu Islands region of Japan at 7:07 last night, and a 4.5 in the same area at 2:07 this morning. Now this one is showing very deep, is showing at 395 kilometers deep. So when we have those deep earthquakes is what makes these tectonic plates move around the planet, because they're all connected. Next we had a 4.2 near Roshtkala, Tajikistan at 5:06 this morning, 169 kilometers deep. Now let's go to all magnitudes map and hop down to the Dominican Republic. We're showing 12 here today. I'll just click them and call them off. 2.6, 2.5, 1.1, 2.4, 3.0, 1.9, 1.9, 3.6, that's the highest one so far, 1.4, 2.4, 2.8, and 2.5. So that's what's going on down there. Now let's move over to Hawaii. We only seeing one reported. 2.7 near Honoka'a, Hawaii at 4:52 this afternoon, 43 kilometers deep. At Mauna Kea. So there's that. Now let's move on up to Alaska. I'm highly interested in what's going on up here. First of all, we've got this, the largest one was a 4.8, and it was off the coast. It says Alaska, but it looks like it's to the west of Canada, but that's Alaskan territory, and it's right on that red line where that San Andreas fault then comes up, and then it, this is actually this is the Cascadia subduction zone, so it's on the left of that, and then this is the Pacific plate, and then the North American plate, where these two come together. So this is a highly active region. It was a 4.8. They're calling it near Craig, Alaska at 3:11 this morning, 28 kilometers deep. I already checked this tsunami warning earlier, and there was no tsunami threat from this earthquake. Next, 2.1 near Akutan, Alaska at 6:44 last night, 56 kilometers deep. Then coming on up, let's look at the ones that are 2.5 magnitude and higher first. We've got 5 here. We've got a 3.2 near Old Iliamna at 1:21 this morning, 102 kilometers deep. A 2.9 near Big Lake at 10:23 this morning, 20 kilometers deep. A 3.6 near Deltona at 2:26 this afternoon, 7 kilometers deep. 3.7 near Badger at 3:39 this afternoon, 20 kilometers deep. And a 2.5 near Manly Hot Springs at 4:23 this afternoon, 8.6 kilometers deep. So, see if we can get all of these on the map. So all magnitudes for Alaska is showing 50 today. So that's average. They average between 50 and 100. What have we got here? Oh, we've got a little pair here. So this 3.6 also had a 2.2 just like 6 minutes afterwards. And that 2.2 was at 0 kilometers depth. I'm seeing some around here, like this Cantwell, Alaska, at 0 kilometers depth. So that's right up here. So when it's that shallow, you have to wonder what's going on. Here's a new one, a 2.1 near Chitina, Alaska at 4:09 this afternoon, 0 kilometers depth again. It just kind of raises a red flag for me. Here's a 2.0 near Sutton Alpine. Here's a 2.0 near Cantwell, 6.6 kilometers deep. 2.0 near Talkeetna. So a lot of 2s. 1.5 near Talkeetna. 2.4 near Big Lake. And so this Anchorage area right up here is where they had that 7.1 not too long ago. So that's calmed down today. We're only showing 16 in this area today. Now if we zoom back out, there's 22 in the area. So now coming down into the lower 48, we're not seeing anything registered from this point over, from the Midwest over to the east. Not seeing anything. But look at all these clusters, and it's straight line all the way down the San Andreas fault line, and a lot of clusters in southern California. And here's a 2.1 in Baja that came in last night at 11:34 p.m. We also have another one here on the southern end of the Juan de Fuca plate, a 3.1 that came in at 12:09 this afternoon. We had one there yesterday as well. And we've got a 2.3 near Petrolia on land, it looks like. Well, right on the coast. So right near where these plates all come together. So that's a highly active region. That one happened at 12:32 this afternoon. So this one was at 12:09. So less than 30 minutes later was this 2.3 right straight across. Then we have a 2.2 near Manton, California last night at 7:17 p.m. at a minus 0.8 kilometers depth. So you know what that means. It means there's activity up in the mountain. The magma is moving up in the mountain. Let's look at Google Earth just to see. I'm just thinking that's just somewhere out in the middle of nowhere in the mountains. I'm trying to learn reading Google Earth better, so the only way you learn it is by using it. So even though I'm not very good at it, I'm going to use it. Here we go. Whoa. You kind of get motion sickness zooming in so fast. Okay, it looks like it's on the edge of a forest. Like this is forested land here, and this is doesn't look like forest here. So it's right there. That's where it happened. So that's north of Highway 36, it looks like, I think. Yeah, that's Highway 36. And it's near, okay, this is Paynes Creek that's going by the highway. Here's Ishi Conservation Camp, whatever that is. Here's Manton, that's the reporting station. Shingletown. And then Cottonwood. So here's Highway 5. So look, here's Lassen. Here's Lassen Volcano. Lassen National Forest. Let's see how far it is from our epicenter here over to Lassen. And Mount Shasta is right up here. So we'll get our measuring. And so we were right about here at Paynes Creek and up to the Lassen area. "45 kilometers. It's 28 miles. So that's not very far. And from Shasta, let's do a new one. Shasta is right about, there's Shasta Lake coming down to this area. It was right about here, done. 30 miles. So it's in the middle of volcano territory. Definitely. And Redding is right up there. So 2.2. And that's the largest one we're seeing for a ways, and it's only one up here in Northern California besides this one at Petrolia. So not quite ready to do California yet, though. Let's look up here in Washington and see. We've only got one being reported, a lone 1.5 near Desert Air at 12:35 this morning. 20 kilometers deep. Nothing being reported out of Yellowstone. That's eerily quiet. Nothing being reported out of Utah. That's eerily quiet as well. Colorado is quiet. Wyoming. It's just amazing how many we can have in one day, and the next day is like what happened. So let's go to Nevada next. Here was a 1.0 near Ely at 10:34 last night. And southern Nevada, we normally have a few small ones. We've got 2 little ones down here. Here's 3 in the Hawthorne area. Here's a larger one, 1.4 near Gabbs, that happened at 1:58 this afternoon. Here's a new one that just came in, 1.1. This is southeast of Fernley at 6 o'clock. It's 6:30 right now. So 6 o'clock this evening, 1.7 kilometers deep. So it's on the way to Fallon. It's on right, looks like it's right on the highway. Yep. So here's Fernley. Here's Wadsworth over here. And that Reno Tahoe Industrial Center is out here. It's all out here. They're still building. It's going from 80 all the way down to 50, down to Silver Springs almost. It's a huge area. And Google is going to be out there. Switch already is out there. Tesla Motors, or Tesla with the battery, lithium batteries, they're already out there. Blockchains, they're building, they're out there. I've talked about all of that. So anyway, now let's look at Reno. We've got one little itty bitty one in Mount Rose area, a 0.3 that came in last night at 10:41. So that's it for Nevada. Now let's go to the geysers. We've got 17 today out of 40 something yesterday. So these are small. These are the largest of 1.5, it looks like. Most of them are under 1. So there's that. Then coming on down, we've got 3 kilometers northeast of Oakland. This was a 2.8 that came in at 10:41 last night, 7 kilometers deep. And right next to it was a 0.8 that came in at 12:59 this morning, 7 kilometers deep. So just a couple of hours later. So they're happening in pairs. Remember, we see them coming in pairs like that. Coming on down this San Andreas fault line, 1.2 near Interlaken. Here's a 2.5 near San Juan Bautista at 12:04 this afternoon. 1.9 near Ridgemark at 8:22 this morning. 1.9 near Pinnacles at 11:19 this morning. Now Southern California, they're just kind of peppered around in the city. So here's that one down in Baja, a 2.1. And then, see if we can get all of Southern California on the map here. 44 here today. That's a pretty good number, considering it's a Saturday. Let's just pick out some of these larger ones. Here's 2.5 near Loma Linda at 8:05 this morning. 1.3 near Avocado Heights at 8:39 last night. Let's see what's going on down here. 2.9 near Ocotillo Wells. Now we saw a cluster down here yesterday, remember? And we've got, they're not that far away. We've got a whole bunch all in this area. We've got 14 on the map right here. So here's a pair. Here's a 2.0 and a 2.9. So the 2.0 happened at 7:46 this morning, and then 4 minutes later the 2.9 happened at 7:50 this morning. So why is the 2.9 dot smaller than the 2.0 dot? That seems backwards, but anyway. Now let's come up this eastern side, see what's here. It's quiet. We've got a 0.6 near Little Lake. That's it. Very quiet. It makes me kind of nervous to see it that quiet, really. There's a 1.7 that just came in near Hawthorne, Nevada. We saw that 1.1 at Fernley. So to see it that quiet makes me a little nervous. Either some of them are not being reported, which is usually the case, or something big is building. But look at that line of 3 all the way across. Isn't that interesting? So let's zoom out and see if anything else came in. Oh, yes it did. Yes it did. We've got a 4.6 that just registered near Somlaki, Indonesia. This just came in at 6:18 this evening, 145 kilometers deep. So it's near this other one that came in at 4:30 this morning, a 4.7. So this is a 4.6. So it's in the ocean, so right on the red lines. So I think that's a wrap. So I will sign off for now. And everybody remember to move your clocks forward an hour tonight when you go to bed, if you're going on daylight savings time. And I will see everyone probably tomorrow. And I love you all, and I do believe that time is very short. No one knows the day or the hour, so you just better be prepared. But from what we're finding with all of these new reports and things and research that people are bringing, is that things are happening much faster than we thought, and so the end is nearer than we thought. So if you haven't gotten right with God and Jesus, now would be a good time. I love you. God bless you. Go in peace, and goodbye.